UTHM.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Fermanshah bin HASAN. And in today's video, I will demonstrate the development process and as well as the simulation of Lab 5.8 on how to control stepper motor with Arduino. Before we get started, you need to have Arduino Uno library downloaded into your Proteus library. So first thing first, open Proteus software, select new project, rename the file as you wish, and then just click next since we're going to use the default settings. Next step, import all devices needed into device selector. The components needed are Arduino Uno, stepper driver, stepper motor, resistors, and LED. Then, set up the Arduino Uno V3 with 8 terminals, where 4 terminals are for the stepper and the other 4 is for the LED indicator. Next, set up 4 LED and a 220 ohms resistor connected with 1 terminal for each LED. Make sure to connect all the LEDs cathode to the ground. In order for the Arduino to control the stepper, we must use a driver as the intermediate. So in this case, connect all of the input terminal of stepper motor respectively into the 1C pin until 4C pin on the driver. 2 pins on the middle will be connected to power supply. Then, connect 1B until 4B pins with a floating terminal. These terminals are the one that connected to the Arduino. The overall circuit diagram will look like this. Moving on to the Arduino program. So first thing first, declare all pins used on Arduino with its respective output, which in this case is the stepper and LED. Based on the circuit, the pins used for stepper are pin 8, pin 9, pin 10, and 11, while the LED indicator uses pin 3, pin 4, pin 5, and pin 6. So the code will look like this. Then set the delay time to 200 milliseconds. On the void setup section, declare all terminals as output, and the program will look like this. On the void loop section, set the motor pin 1 until motor pin 4 to high state one at a time, and as well as the LED indicator. Set a delay on each changes. Since the code is under the void loop section, the program will keep repeating until the power supply disconnected. The overall coding will look like this. Next step, export the hex file of the code and upload it into the Arduino in simulation. Start the simulation and there you go. Essentially, stepper motors offer excellent speed control, precise positioning, and repeatability of movement. Plus, compared to a DC motor, there are no contact brushes in the stepper motor. This minimizes mechanical failure and at the same time maximize the operation lifespan of the motor. And that is why This stepper motor is widely used in many applications, as many different rotational speeds can be achieved by simply controlling the frequency of pulse input. The application include the rotating needle of an analog clock, camera lenses, computer printer, and many more. Generally speaking, any application that requires highly accurate positioning, speed control, and low speed torque can benefit from the use of stepper. And I think that's all from me. Thank you and see you soon.